Welcome to the session. Greeting of the day. In today's class, we are going to see about the various pneumatic actuating systems. We have seen in previous classes that in the actuating drive mechanisms, drive or actuating systems, we have divided into electrical actuating, mechanical actuating, then hydraulic actuating, and then now we are dividing into the pneumatic actuating systems. Now we are going to see about this pneumatic actuating systems and their few types. It deals with to study the behavior and applications of a compressed air in the manufacturing automation. We are using in the pneumatic. The word pneumatic belongs to a Greek word which represents the wind. So wind is nothing but the air. We are using here the air for the compressed force to actuate at the other end. It should take the action. So for that purpose we are using this air or wind. So that is why it is named as a pneumatic systems. The pneumatic is mechanized we are doing. Now we are using this compressed air we are sucking into the mechanisms, a machine setups, a compressor, and then this compressor will to give the more force there. So that we are going to do, and we are using this in our automation purposes. Use of air as a medium, used in oil refineries, gas pipelines, chemical plants, natural gas processings, everywhere we are using this. And air conditioning and refrigeration systems also, blowing of the plastic bottles. Specifically, we could have seen this air blow molding process. So in the blow molding process, we are using this air pressurizing, and compressor is used to push the compressor air into the cavity in such a way bottles or frames are formed. So such case of blowing of plastic bottles made up of polyethylene PET membranes. So introduction of mechatronic systems, now we are going to see from here. So these are the requirements. We are doing these pneumatic systems for actuating some other actions in the oil gas industries, in the blow molding process, and air conditioning refrigerations everywhere. So how we can give this introduction part? It contains, in general, we have this is a system. As by the term, it is a actuating system. Right? So we need the actuation at the one end. Here I need the actuation. So this is the total circuit of the pneumatics. The wind, the air circulations, it is compressed here and it is operated through the control valve to make such action in such a way it can move. Action is taking place here. Action is movement of this piston causes the action. So to movement of this piston may be the action. I have this many setups in the pneumatic actuating systems. See the pneumatic actuating systems. What it does? It contains, first initially I have taken the air from the atmosphere, from the environment. After that what happens? The environmental air may contain the dust particles, it may contain the impurities on the air to be filtered. Otherwise what happens? It may go into the system, it may stop the holes, it may block the holes, therefore the further processing may not take place. Therefore, I am putting the initial at the starting point itself filter. The dust impurities has been filtered out. Further, I'm using a compressor. I'm using the compressor in such a way, this compressor is going to receive and compress the volume, and then it is going to give the outlet. In such a way, it is have to process for the further. So here we have many types of compressors. Types of compressors that we have to see. So this have the single acting compressors, double acting compressors. So with respect to single acting, double acting, the pressure of the air which is taking in and taking out are increased. From 5 bar to 10 bar it is increased. So such a compressor does its job to make action there. Make action here. So now after compressor, due to this air having this compression state at a normal room temperature, it is at a normal temperature. At a normal room, air is also at a normal. When it has been compressed, it is sensitive to the temperature. Air is sensitive to the temperature. Therefore, when the volume of the air is compressed inside the compressor, automatically the temperature increases. Volume reduction gives the temperature increment. So we are reducing the volume and we need some pressure there to move. Normal air is surrounded us. This is not doing anything else. But in case of wind, in case of cyclonistic air, what happens? We are pushed out. Therefore, that compressed air we are doing here, this compressed air will increase the temperature. What happens now? This temperature should be reduced, and we need the pressure to move the object. So what I'm using a cooler here in which it may contain a circulating water, a heat exchanger. We can consider as a heat exchanger. Therefore, when the compressed hot air passes through this, and the hot air passes through these conditions, what happens? You see, it transfers the heat here, and it is already compressed, but temperature is there, but temperature to be taken out and the air to be taken to the operations. So we are keeping a cooler heat exchanger, and therefore the heat is transferred there, and then the remaining normal air is again coming here to the reservoir. So the separator divides the further recycling process of hot airs, and we again coming to the reservoir. So what is the reservoir? It is nothing but a storage tank where compressed airs are again it's coming and we are storing here. It is stored. If the pressure is increased on the specific reservoir volume, reservoir pressure bar is exceeding this reservoir room or reservoir tank, it has to be released. Therefore, I have a pressure switch in such a way the pressure can be released back. It can be recycled. It is a motor controlled center to recycle if it is exceeded. So we need safety precautions that I have did there. In such a way, the safeties, air if pressure is increasing, we have to. Now, and again from the reservoir, we have not started to move. We have not started to move the object. Still we are filtering, still we are transferring the temperatures, still we are storing. And now again, I am putting one more air filtration, air treatment process. Maybe the dust, then maybe the impurities, because it is getting recycling. There is a chance of coming there. Therefore, again, I am putting one more air secondary air treatment processes. And then from there, from all these pressure regulation conditions, I have connected to the control valve. So this control valve is going to do the job whether I want to move the object front or I want to move the piston backward. So accordingly, this control valve is going to act. So this control valve will give two positions are there. One position goes to this direction and another position leaves the air in this direction. So what happens? When the air is at position A, it means this position A. The air goes through this end, this is position A. Air coming, this is port A, this air coming, this is port B. When the air goes through port A, piston moves in the right direction. When the same air goes through port B, the piston wanted to move in the left direction. This direction. This is go to this direction. So accordingly I have actuated the piston. In case I have a load here to move forward and I want to push the object frontward, what I can do? I am actuating the air port through pneumatic, through compressed air. It has a force, therefore the force pushed there. How fast we are pressing there, how fast this piston is going to actuate. So that is how we can able to do. And now I want to return back. Again, second object has been kept. Again, pushing, it should move. It should return back. Third object keeping, pushing, movement of the object and coming back to the original position. So again, I am supplying the air circulation through port to B. It will come back to the original position. Such how this pneumatic system works. Filter, compressor, cooler, separator, receiver and secondary treatments, control valves and the working object of pistons actuating system, actuator. So this is given, actuator. Now what we have seen, it is given the theoretical we should understand this. Air filter. This air filter out the contaminations from the air, dust particles, impurities it is going to remove. And compressor, next part we have seen. The compressor, you see, it reduces the volume of the air and increases the pressure. The air is compressible, not like a fluid. Air is compressible. So it can be compressed, volume can be reduced and pressure, if the volume is reduced, obviously we are compacting, pressure is increasing. Even if we are putting into a small box, we will be pressurized and when we waking up, high pressure will come. That's like reduced volume of air increases its pressure. And also the air cooler is there, the next one. It reduces the temperature of the compressed air. See, it came. Volume reduction, temperature increases. So this temperature increases is relieved by this air cooler. Relieved by this air cooler. Next, dryer. If further some maybe water this contains, this because the cooling process happens, condensation will happens, therefore it will be wet. So wet air to be dried out to the actuating mechanisms. So the separator separates the vapor or moisture from the air. So we have seen this separator here. So this also I am writing here as a now dryer. Okay, so likewise we can able to understand the separator term as a dryer. Control valves. Next, where is the control valve? There. From the reservoirs, we are going to the control valve now. Reservoirs, this is storage. And then it again is going to release. Regulate, control and monitor the control, whether it is to be in the A condition or otherwise it is to be in the B condition. Where the supply to be given, where the force, where the air to be, where it should go, within the A or it should go in the B circuits. And the air actuators, that cylinder. This cylinder, air cylinder. Air cylinders and motors are used to obtain the required movement of mechanical elements of the pneumatic system. So it is the object which receives this pneumatic circuits, pneumatic pressure, and it is going to do the function of movement, of actuation. Then we have additionally the electric motor and reservoir tanks. Transforms the electrical energy to the mechanical energy, transforms this electrical energy to the mechanical energies from these electrical motors to function of these things. You see, here we have motor control, maybe to rotate the compressors, and this reservoir of safety purposes, we have those things. And then the reservoir tank, here we have this reservoir tank to be, after dryer we have storing. Okay, so at last it's just a storage. The compressed air coming from the compressor, the compressed air coming from the compressor, the compressed air coming from the compressor is stored in the reservoir, is stored in the air reservoir. So that is how we understand the components of pneumatic system, and also this functions, how it from one end, from the filter to the movement of the object, we came to know. The basic components of pneumatic system. Now I'm simply only one reservoir I'm seeing here. What this reservoir contains? Reservoirs, generally we have told it is a storage system. But also you see, it having the inlet, it should be maintained, or otherwise it should blast, because we are compressing air here. If safety precautions to be monitored well, otherwise it should cause the accidents. So the inlet, so this area is the storage where the compressed air is going to store. For cleaning purpose, or otherwise for verifications purposes, we have a manhole through which the man has to go inside this reservoir, large reservoir tank, and he should do the inspection whether the reservoir have been made or welded or casted in the proper format. The cracks, defect should not be there, the leak proof to be verified. Otherwise we will keep on compressing, the leak proof or the leak, we would say it is keep on going, there is no use. Therefore, a manhole is kept for the fabrication purpose and for the repair purpose. So this manhole is at one end. And at the top other conditions are there, you see. At one side, here we have a water drain. The compressed air, but it is water drain. If it is converted due to conventions, it should change these conditions from air should be drained out. This is one end. Then at the top, if the pressure is increased, we are going to relieve this pressure relief valves. What is the, it is going to relieve, but what is the pressure? We have to verify. That is pressure gauge. Then this all accident takes place with respect to increasing in temperature. Volume is reduction and compressed here. At the same time pressure is verified. At the same time temperature also to be verified. With respect to temperature or pressure, we can able to understand what is the situation there. Whether it is the safe level or exceeding the safe level. So the temperature thermometer is utilized to measure that also. And then the outlet. So here the inlet is there of air inlet, and here is the outlet is there. Outlet. So there is a shut-off valve. I have closed the shut-off valve and I can able to fill. When it is required, I can able to move or open the shut-off valve and then it can go. So this shut-off valve can be operated using solenoid actions to drains. So using PLCs, we can be able to control these compressors in such a way, when it is exceeding the pressure, it can able to open the outlet. It can, when the exceeding pressure, we can be able to open the drain out. So such PLC programming also can be incorporated here. This is one part. So compressed air is stored in the air reservoir. Yes, and then the smoothness of the pulsating flow from the compressor. It helps the air to cool and condense the moisture present. So that is what the main intention of this. Helps the air to cool down, because when we are compressing, it increase in temperature occur. But that increase in temperature we not needed. We need air, the compressed air, to move the action takes place. To actuating mechanism, we need to pressurize 10 bars or 50 bars or 90, 100 bars. But we no need of temperature, we should remove that. That is why we use the cooler or heat exchangers And also here when it is stored well, slowly it is going to condense, temperature is going to reduce. The size of the reservoir depends on our applications. How much size it is, whether the reservoir can be this size, or reservoir can be this size, or reservoir can be this size. It depends upon our applications, where we are using, what is the intention, what is the load we have to push. Depending upon those conditions, I am fixing the size of the reservoir. So according to the delivery volume of the compressor, how much the delivery volume we have to store, and what is the function daily, what is the function per hour. So depending upon that, we can able to purchase or make the compressor size. Air consumptions, how much it is, and the pipeline networks, how much it flow, how far it is taken out per minute. And such a way the inlet also to be given, keep on inlet to be given, keep on outlet to be taken. How far? Types and nature of the on-off regulations, permissible pressure differences in the pipelines, and depending upon those, these reservoir tanks are fabricated. The summary. In today's class, we have seen about the various types of pneumatic systems, the various components of pneumatic system, and also we have seen some of the types of compressor. Likewise, a piston compressor, likewise a multi-stage compressor. The remaining part of the subjects we'll see you in the next session. Thank you.